Now let us say that t is the period of fx, so f of x plus t would be equal to f of x. Now let us say that this is any point x equal to a, and so as this is a periodic function, we have plotted the graph of fx, and this point becomes n times t plus a. Now we see that this area is equal to this area, and we have to calculate integral of a to a plus n times t into fx dx. Now we can say that we have to calculate this area plus this area plus this area plus this area plus this area, but we can also say that this area is equal to this area, so it is actually from this area to this area. That is, the integral of a to a plus n times t into fx dx is equal to this area plus this area plus this area up to this area. We neglect this area because this area is equal to this area, and hence integral of fx dx from a to a plus n times t is nothing but equal to 0 to n times t into fx dx t. Thus the integral of a to a plus n times t fx dx is equal to integral of fx dx from 0 to n t. Let's look at property number 8. It says that integral of fx dx from 0 to 2 times a is equal to integral of fx plus f of 2a minus x dx from 0 to a. Now this is equal to 2 times integral of fx dx from 0 to a if f of x is equal to f of 2a minus x, and this is equal to 0 if fx is equal to minus of f of 2a minus x. So this property says that the integral of fx dx from 0 to 2a is equal to integral of fx plus f of 2a minus x times dx from 0 to a. Now this would be equal to 2 times integral of fx dx from 0 to a if fx is equal to f of 2a minus x, and this would be equal to 0 if fx is equal to minus of f of 2a minus x. So let's look at the proof of this. We can write integral of fx dx from 0 to 2a as fx dx from 0 to a plus fx dx from a to 2a. We can split this interval 0 to 2a into 0 to a and from a to 2a. Now let us make a substitution that x is equal to 2a minus t. So when we differentiate both sides, we get dx equal to minus dt. Now if x is equal to a, t would be equal to a, and when x is equal to 2a, then t would be equal to 0. So let's look at this integral. Integral of fx dx from a to 2a would be equal to minus of integral of f of 2a minus t dt from a to 0. We have substituted these values here. Now this would be equal to integral of f of 2a minus t dt from 0 to a, and this would be equal to integral of f of 2a minus x from 0 to a. Thus we can say that integral of fx dx from 0 to 2a would be equal to integral of fx dx from 0 to a plus integral of f of 2a minus x from 0 to a. Now let's look at the last set of properties, that is property 9th and property 10th. If fx is a periodic function with period t, then the integral of fx dx from a plus n times t to b plus n times t is equal to integral of a to b fx dx, and integral of fx dx from m times t to n times t is equal to n minus m into integral of fx dx from 0 to t. So if fx is a periodic function with period t, then we have got two properties. The integral of fx dx from a plus n times t to b plus n times t is equal to integral of fx dx from a to b, and the integral of fx dx from m times t to n times t is equal to n minus m into integral of fx dx from 0 to t. So let's try to understand these two properties. Now we know that fx is a periodic function, so the period is t. Now this is the graph of fx. Let us say that this is the point x equal to a, and this is the point x equal to b. This point is x equal to t. Now this is I, and this is nothing but integral a to be fx dx, and this is the point a plus n times t, and this is the point b plus n times t, because simply we can add n times t here and n times t here to get these 2 points. Now again, as this is a periodic function, we see that this area would be equal to a plus n times t to b plus n times t fx dx. But this is a periodic function, so this area is equal to this area. We can clearly see in the graph here. So we can say that this I is equal to this I, and so integral of a plus n times t to b plus n times t fx dx is equal to integral of fx dx from a to b. Thus the condition is t is the period of fx. Again, let's look at the 10th property. We say that this is fx. This entire portion is the graph of phi equal to fx, and t is the period. Now we know that fx is a periodic function, so it repeats itself after a fixed period, that is t. Now we see that m into t, m plus 1 into t, and so on up to n times t are nothing but multiples of period. So this area would be equal to this area, and so on. This we have already seen up to this area. This entire area from m times t to n times t would be nothing but fx dx from m times t to n times t is nothing but equal to the sum of all these areas. The number of these areas is n minus m into I, but we also know that I is equal to integral of 0 to t fx dx. Somewhere it would be something like this, and t, this portion, and this would also be equal to I. Hence I is equal to integral of fx dx from 0 to t. Thus this is equal to n minus m into integral of 0 to t fx dx. So we have seen enough of properties. Let's try to apply these properties while solving problems. So let's see an IIT problem that appeared in 2004. Evaluate integral pi plus 4x cube divided by 2 minus cos of modulus of x plus pi by 3 from minus pi by 3 to pi by 3. So in this problem we have to calculate the value of integral of pi plus 4 times x cube divided by 2 minus cos of mod x plus pi by 3 from minus pi by 3 to pi by 3. So in the first step, what we do is we break the numerator into two parts. So let us say that I is equal to integral of pi by 2 minus cos of modulus of x plus pi by 3 from minus pi by 3 to pi by 3 plus integral of x cube pi 2 minus cos of mod x plus pi by 3 from minus pi by 3 to pi by 3. Now what do we observe here? We observe here that this function is odd and this function is even. Now we know that integral of minus a to a fx dx is equal to 2 times integral of fx dx from 0 to a if fx is even and is equal to 0 if fx is odd, and hence this entire term is odd function. So this integral would be equal to 0, and this is an even function, so I would be equal to 2 times integral of pi by 2 minus cos of modulus of x plus pi by 3 from 0 to pi by 3. Let us make a substitution that x plus pi by 3 is equal to t. Differentiating we get dx equal to dt. So this integral would become 2 pi into integral of dt by 2 minus cos t from pi by 3 to 2 pi by 3. So what we can do here is we can write cos t equal to 1 minus tan square t by 2 divided by 1 plus tan square t by 2. So we substitute the value of cos t over here to get I equal to 2 pi into integral of sec square t by 2 divided by 1 plus tan square t by 2 from pi by 3 to 2 pi by 3. Now again we make a substitution, that is tan of t by 2 equal to y. So sec square t by 2 into dt would be equal to 2 times ty, and so when t is equal to pi by 3 we get pi equal to 1 by root 3, and when t is equal to 2 pi by 3 we get y equal to root 3. So we substitute these values in this integral to get I equal to 2 pi into integral of 2 times dy divided by 1 plus 3y square from 1 by root 3 to root 3. Now this becomes 4 pi by 3 into root 3 tan inverse root 3y from 1 by root 3 to root 3. So we put these values to get the final value of I equal to 4 pi by root 3 into tan inverse of 3 minus tan inverse 1. Tan inverse of 3 minus tan inverse of 1 would be equal to tan inverse of 3 minus 1 divided by 1 plus 3 into 1, because tan inverse x minus tan inverse y is equal to tan inverse of x minus y divided by 1 plus x into y. So this would be equal to tan inverse of 1 by 2, and hence finally we get the value as I equal to 4 pi by root 3 into tan inverse of 1 by 2. Let's try to solve one more IIT problem. This problem appeared in 1995 and it says that determine the value of integral of 2x by 1 plus sin x divided by 1 plus cos square x from minus pi to pi. So in this problem we have to evaluate the value of this expression. So let us say that I is equal to integral of 2x into 1 plus sin x divided by 1 plus cos square x from minus pi to pi. Now again we are going to split this term into two parts as I equal to integral of 2x into dx divided by 1 plus cos square x from minus pi to pi, plus the second part is 2x into sin x divided by 1 plus cos square x from minus pi to pi. Now this is an odd function and this is an even function, so this would be equal to 0, and so we get I equal to 2 times integral of 2x sin x divided by 1 plus cos square x from 0 to pi. We take 2 from here to get I equal to 4 times integral of x sin x divided by 1 plus cos square x from 0 to pi. Now we are going to use the property that integral of fx dx from a to b is equal to integral of f of a plus b minus x from a to b. So I would be equal to 4 times integral of pi minus x into sine of pi minus x divided by 1 plus cos square pi minus x from 0 to pi. So what we do is this term would remain the same as sin x, this would become cos square x, and so we again split it into two parts as I equal to 4 times integral of pi into sin x divided by 1 plus cos square x minus 4 into integral of x sin x into dx divided by 1 plus cos square x from 0 to pi. Now we see that this is nothing but equal to I is this term, so this would be equal to I, and so we get 2I equal to 4 pi into integral of sin x by 1 plus cos square x from 0 to pi, or I would be equal to 2 pi into integral of sin x dx divided by 1 plus cos square x from 0 to pi. Now what we do is we substitute cos t equal to t, so minus sin t would be equal to dt. So I would be equal to minus 2 pi into integral of dt by 1 plus t square from 1 to minus 1, or 2 pi into integral of dt by 1 plus t square from minus 1 to 1. Now integral of dt by 1 plus t square is tan inverse t, and so I would be equal to 2 pi into tan inverse of t from minus 1 to 1. Now the value of this is pi by 2, and so I would be equal to 2 pi into pi by 2 or equal to pi square. Thus the final value of I